Going to look at how you would find the time of Merpass for a planet. By time we mean GMT in this case, because we're going to need to find GMT in order to find the declination and do the calculation. So the first step in any Merpass calculation is going to be working out the GMT of Merpass. For the Sun, you might have been using the LMT figures from the daily page with a longitude and time applied, which is fine for the Sun. You can get a GMT to the nearest minute, which is adequate to get you your declination. The method we're going to use today, though, is using the assumption that at Merpass, LHA is going to be 0, or 360. And that's because at that point the body is on the observer's meridian, so the angle between the observer and the body at the pole is going to be 0. And that's the local hour angle. In this case, we're going to be finding the GMT of meridional passage of the planet Saturn. And the date we're going to be looking for is the 6th of February. And we want the time of Merpass. It's going to be GMT for Saturn. Our DR in this case is 12 degrees 14.8 north and 016 degrees 10.7 west. We're going to start with our LHA, which we know to be 0 or 360, which are obviously the same. But because at the moment we're using a westerly longitude, I'm actually going to put it in as 0. And this is because if I'm going to work backwards to get my GMT from this, I first need to work back and work out, based on my longitude, what the GHA of the body would have to be to give me that LHA of 0. So I'm going to put in my longitude here, and because it's west and I'm working backwards, normally going from GHA to LHA we'd subtract west, but in this case we're actually going to add it on because we're working back to GHA from LHA. So I would have a total GHA there that's actually equal to my longitude in this case, my westerly longitude. Of course, had it been east, I would have been subtracting it and I would have started with 360. But because it's west, I've started with 0 and I've got a GHA that's equal to my longitude. Now, if you think back to doing any calculation that requires you to get the LHA, you'll remember that your GHA is made up of various parts, and one of those parts is going to be an hourly value from the daily page. So if we look back over the date of the 6th of February, and we've got the star Saturn here, you can see that the GHA values down this column are increasing throughout the day. And we can see this GHA of 01610.7 actually falls sometime between 1 and 2 AM on the 6th of February, GMT, for Saturn. Now what this means is, we know that it's going to be past 1 AM, but not yet 2 AM for this one. So the GHA for 1 AM is 15 degrees 09.8, and whatever is left over once I subtract this 1 AM GMT from this GHA is actually going to be what's made up of my increment for the minutes and seconds, and also, because this is a planet, the V correction of the planet. So whatever's left after I take this hourly value from this total GHA, I'm going to need to account for in terms of increments and a V correction. So first of all, let's subtract the 1 AM GHA from my total GHA value. And what I'm left with is 1 degree 00.9. And I know that this 1 degree 0.9 minutes is made up of, on the one hand, some kind of increment, which is going to be the equivalent of a certain number of minutes and seconds, but I've also got to consider my V correction. Remember, for Saturn, because it's a planet, it has a V correction, and in most cases V corrections are added on. The only time it might not be added on is if you're using Venus and Venus has a little minus sign there, but Saturn is always going to be positive, and that V value of 2.7, we're actually going to look up the V correction from the same place that we get the increment from, so that same table within the increments tables. So I'm just going to put 2.7 on there. Now normally, again, we would be adding on whatever that value is to our hourly GHA and our increments in order to get the final GHA. So in order to get that 16 degrees 10.7, because I'm working backwards this time, I am going to end up subtracting this V correction, and whatever's left is going to be my increment. Now, to get me to the right sort of area for that V correction, I'm going to turn to the back of the almanac, and I'm just going to look through the increments tables. You can see down here the values for sun and planets are in this left hand column, and I'm moving back through the hour and they're getting lower and lower, and I'm looking for something in the region of 1 degree 00.9. Now you might not get this exactly, but really the most important thing for the time being is we get to the right minute in the increments tables. So 1 degree 00.9, you end up somewhere in the 4th minute between 3 and 4 seconds initially. So this increment equates to about 4 minutes and 3 or 4 seconds. However, the first thing we have to take into account is this V correction. Now in the 4th minute, the V correction for 2.7 is 0.2. I've just read that from this side of the table here. So read down to 2.7 and I can see the correction is 0.2. This correction of 0.2 has to be subtracted from this value before I can then turn this value into minutes and seconds as an increment. So actually, within this column, rather than looking for 1 degree 00.9, I'm actually looking for 1 degree 00.7, because I've actually taken that V correction off. 1 degree 00.7 isn't spot on any of these values, but we're still in 4 minutes obviously. But if you look at 2 seconds, we've got 1 degree 00.5, and at 3 seconds we've got 1 degree 00.8. Now my 0.7 is closest to 0.3, so I'm going to call this 3 seconds, which gives me a final GMT for this Merpass as 01, 04, 03. And that is GMT of Merpass for Saturn in this position on the 6th of February.